Hello everybody. So in this class we solve one more problem on simultaneous differential equations. So here the problem is solve the simultaneous equations d square x minus 3x minus y equal to e raised to t and dy minus 2x equal to 0. So this is a problem. Now we first write the given equations. D square x minus 3x minus y equal to e raised to t, and then dy minus 2x equal to 0. Now this is equation 1 and this one is equation 2. Call these equations as 1 and 2. Okay, so now what we do, we eliminate one of the unknown. Okay, we eliminate one of the unknown. So but before that, further we can simplify this equation. So this means here we can take x common, d square minus 3 into x minus y equal to e raised to t, and the second one dy minus 2x equal to 0. So this is equation 3 and this is equation 4. Okay, so now we have to eliminate one of the unknown. You can eliminate either x or y. Okay, so make always the procedure is simple. Make procedure simple. So what I do, I eliminate y. And to eliminate y, I should make the coefficient of y same. Correct? So here we have y and y's coefficient is 1, and here we have y and its coefficient is d. So we have to make the coefficient same. So what I do, I operating d on equation 1, sorry, on equation 3, operating d on equation 3. Okay, so we obtain d square minus 3, so dx minus dy equal to d into e raised to t equal to d into e raised to t, or d of e raised to t. So d means differentiation. Okay, so which gives d square minus 3 dx minus dy equal to, now d of e raised to t, d means differentiation, so differentiation of e raised to t is e raised to t only. Here we write, because d of e raised to t is equal to e raised to t only. Okay, now we take the fourth equation. Now that is dy minus 2x plus 0. Okay, so now add these two, so here this plus dy minus dy get cancelled, then what we left, d square minus 3d dx minus 2x equal to e raised to t. Adding these two, this will get cancelled because plus sign minus sign, and this minus this 2x is equal to e raised to plus 0 e raised to t. Okay, so now simplify this equation. Simplifying this equation, so we get or taking x common from these two, so which we get d square minus 3, okay, into d 2, taking x common, x is equal to e raised to t. x is equal to e raised to t. Now see here, this is just an ordinary differential equation. This is just an ordinary differential equation. Okay, so on simplifying again this one, this gives d cube d square into d cube minus 3d then minus 2 into x is equal to e raised to t. So now auxiliary equation is what we get, m cube minus 3m minus 2 equal to 0. Now solving this equation, so factorizing this equation, we get, this implies m minus 2 into m plus 1 whole square equal to 0, which means m is equal to 2 and m is equal to minus 1 comma minus 1. Okay, so this means, therefore the general solution is, so all among the 3 roots are there. Among 3 roots, the 2 roots are repeated or 2 roots are same and 1 root is different. So therefore general solution, we write this as gs is equal to c1 e raised to 2x, c1 e raised to 2t, c1 e raised to 2t, because the corresponding to this root, the solution is c1 e raised to 2t, then plus, now these two are same roots or repeated roots, so here we write this as c2 plus c3t into e raised to minus t, so this is the general solution. Next we obtain particular integral. Particular integral is given by pi is equal to 1 divided by, so this is a equation, d cube minus 3d minus 2 of e raised to t, which is equal to, now this is a first rule, e raised to t is there, so to solve this equation, this is nothing but e raised to t divided by, wherever d is there, replace d by 1, t is coefficient 1, so it is 1 minus 3 minus 2, wherever d is there you replace it by 1 because t is coefficient is 1. This is of the form 1 divided by f of d of e raised to ax, so 1 divided by f of d of e raised to ax is 1 divided by f of, we know that, here I will write so this we have learnt in Bsc 4th semester. So when f of x is e raised to ax, then 1 divided by f of d of e raised to ax is nothing but 1 by f of a e raised to ax. Okay, so means you have to replace d by a. So in the same case we have done here. So 1 divided by, this is f of d, we replace d by a means t is coefficient, that is 1, so 1 cube means 1, minus 3 into 1 3, minus 2 okay. So with this the particular integral becomes, particular integral is equal to 1 divided by minus 3 minus 2 minus 5 plus 1 minus 4 e raised to t, e raised to t. So this is the particular integral. So therefore total solution. So therefore total solution means x is equal to, total solution means we have to solve for x is equal to general solution plus particular integral, general solution plus particular integral. So this means general solution is c1 e raised to 2t plus c2 plus c3t e raised to minus t, this is general solution, plus particular integral is this much, so it is with minus, so here minus e raised to t divided by 4, e raised to t divided by 4. Okay, so this is x. Next we find the value of y also, we should find the value of y also. So to find the value of y, now we take equation 2. Now consider equation 2. Consider equation 2. So equation 2 means what it is? It is dy minus 2x is equal to 0. dy minus 2x is equal to 0. Okay. Or which is equal to, which implies dy is equal to, send this term to RHS, is equal to 2x, or 2 into x means what? Just now we found x is this one. So right here c1 e raised to 2t, then plus c2 plus c3t e raised to minus t minus e raised to t by 4, e raised to t by 4. This is dy. Okay, so now to find it y. So y is equal to, now we need the value of y is equal to, this d comes here denominator, so 1 by d of 2 into c1 e raised to 2t plus c2 plus c3t e raised to minus t minus e raised to t by 4, e raised to t by 4. So already we know that d means differentiation. Okay, so d is nothing but differentiation, right? D is differentiation. Next 1 by d means integration, 1 by d means integrating. So therefore y is equal to, so 1 by d means integration, means we have to integrate this. Okay, we have to integrate this. So for that 2 is constant, c1 is constant, integration of e raised to 2t is e raised to 2t divided by 2t is t's coefficient, that is 2, then plus 2, then plus 2c2, multiply these two terms, 2c2 into e raised to minus t, so its integration is e raised to minus t divided by t's coefficient minus 1, and similarly plus 2c3 into bracket now integrate this 2c3 t into e raised to minus t integration, 2 into t e raised to t minus t integration. So just integrate t into minus e raised to minus t. How do you integrate that? So here now integration of t into e raised to minus t dt is equal to, so already we know what is Bernoulli's rule of integration. If one of the two function is an algebraic function, then we apply Bernoulli's rule of integration. So it states that first we write first term as it is t, then integrate the second term e raised to minus t divided by minus 1. Next put minus sign, then differentiate this t, you will get 1. Differentiation of t with respect to t is 1. Next integration of this one, it is e raised to minus t divided by minus, as it is e raised to minus 1. Okay, on next take plus sign, then differentiation of 1 is 0. Okay, so then if differentiation of this first term is 0, then stop the procedure. So therefore this is equal to minus t e raised to minus t, right? Then here minus minus plus, plus into minus again minus e raised to minus t. So this is integration of t into e raised to minus t dt. We obtain this equation. Now substitute this here. Okay, so this is minus t e raised to minus t minus e raised to minus t. Okay, then this is over, then minus 2 into 1 by 4, 2 into e raised to t by 4, 2 ones are 2 2s are, so it is minus 1 by 2. Next integration of e raised to t is e raised to t only. So therefore finally what we obtain, y is equal to, on simplifying this, so here 2 get cancelled, so it becomes c1 e raised to 2t, then here plus into minus minus 2c2 e raised to minus t, then here plus into minus minus 2c3 t e raised to minus t, then plus into minus again minus 2c3 e raised to minus t. Okay, then last term minus 1 by 2 minus 1 by 2 e raised to t, 1 by 2 e raised to t. So this is y. So we have obtained y and also we have obtained x. So these are nothing but the solutions of the given simultaneous differential equations. Okay, so with this I finish this class and continue in the next class. Thank you.